Now we have studied about linear data structure. In this session we are going to study about non-linear data structure. Non-linear data structure. So what is the difference between linear data structure and non-linear data structure? In linear data structure, where the data elements are stored in a linear manner, that is in the continuous memory locations. Example for linear data structures are arrays, stacks, queues, linked list, etc. But when it comes to non-linear data structure, where the data elements are not stored in linear manner, that is, it is not stored in a continuous memory locations. So example for non-linear data structures are trees and graphs. Trees and graphs are of non-linear data structure. So now let's study about what is a tree. A tree is a non-linear data structure. A tree is a collection of nodes which is organized in hierarchical structure. A tree is a collection of nodes which is organized in hierarchical structure. Hierarchical structure is called as tree. Now let's see what are all the terminologies we come across with a concept called trees. So this is the structure of tree. It is in a hierarchical structure. So what is a root node? Starting node of any graph is called as the root node. In a tree data structure, the first node is called as root node. So, in this tree structure, this node is the first node. This node is the first node. Hence, this node is called as root node. This node is called as root node. So, in tree data structure, any tree contains only one root node. We cannot have multiple root nodes in a tree. So, when we have a tree data structure with n number of nodes, we have n minus 1 number of edges. So, what is the meaning of edges? See, n number of node means consider in this tree, count the number of nodes. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 nodes. We have 10 nodes. So what is the edge now? The connections between two nodes is called as edges. So in this graph, these are all the edges. These are all the edges. The connection between two nodes is called as edges. So if we have n number of nodes in a tree, then we have n minus 1 number of edges will be there. So now count how many number of edges are there. We have n minus 1, that is 9. 1, 2, 3, 4, 5, 6, 7, 8 and 9. We have 9 edges. We have 9 edges in this tree data structure. And next concept is parent-child as. Next concept is parent node as well as child node. So what is parent node? The node which is a predecessor of any node is called as parent node. What is the meaning of predecessor? If a node which have child nodes is called as parent node. So in this example, A is a parent node because node A has two children. A node has two child nodes and B has three child nodes and C has two child nodes. Again here E has two child nodes. But E, F, G and H does not have any nodes. So hence in this example, A, B, C, E are the parent nodes. Hope you understand what is parent node as well as child node. The node which is the predecessor of any node is called as parent node. So here A is a predecessor of B and C and B is a predecessor of D, E and F. C is a predecessor of G and H and E is a predecessor of I and J. So what is a child node? The node which is a descendant of any node is called as child node. In a tree, the parent node can have any number of child nodes. In a tree except the root node, all the nodes are the child nodes. Why? Because B and C are the child of node A, D, E, F are the child nodes of B node, G and H are child nodes of C node and I and J are the child nodes of node E. So what is a child node? The node which is a descendant of any node is called as child node. So in that example, the child nodes are B, C, D, E, F, G, H, I and J are child nodes. Except the root nodes, all the nodes are child nodes. So here the parent nodes are A, B, C and E are the parent node. Next is leaf node. So what is a leaf node? So leaf node is also called as terminal node or external node. It is also called as terminal node or external node. So the node which does not have any child node, such node is called as leaf node. So observe in this example, which are all the nodes? They don't have child nodes. Node D does not have any child node. Node F does not have any child node. Node G as well as H does not have any node. As well as I and J nodes does not have any child nodes. So those nodes are called as leaf nodes. So in the example, D, F, G, H, I and J are the leaf nodes. So these leaf nodes are also called as terminal node or external node. Next is internal node. What is internal node? So this internal node is also called as non-terminal node. Is also called as non-terminal node. Also called as non-terminal node. Any node. So in a tree, if a node contains with at least one node is called as internal node, and it should not be of leaf node. So what is the meaning of a node which have at least one node means? So here in this example, node A has 2 nodes, node B has 3 child nodes, and node C has 2 child nodes, and node E has 2 child nodes. So except the leaf nodes, all the nodes are the internal nodes. So in that example, node A, B, C and E are the internal nodes. ಅಂದರೆ ಒಂದು ಟ್ರೀಯಲ್ಲಿ ಒಂದು ನೋಡ್ಗೆ ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಚೈಲ್ಡ್ ಆದರೂ ಇರಬೇಕು. ಸೊ ಅಂಥ ನೋಡ್ಸ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ? ಇಂಟರ್ನಲ್ ನೋಡ್ ಆರ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ನಾನ್ ಟರ್ಮಿನಲ್ ನೋಡ್. So the next concept is level of a tree. Level of a tree. In a tree, each step starts from top to bottom is called as level of a tree. In a tree, each step from top to bottom is called as level of a tree. So the level count starts from 0. Level count starts from 0. So this is at level 0, and this is level 1, and this is level 2, and this is level 3. So the level of this graph is 3. If they ask, write the level of the given tree means you have to write it as 3. Next is height of a tree. Height of a tree. The total number of edges. The total number of edges from the leaf node, from the leaf node to a particular node, to a particular node in its longest path is called as height of a tree. Height of a tree. So what is the height of a tree? The total number of edges from the leaf node to a particular node in its longest path is called as height of a tree. In this tree, In this tree, I want to find the height of a node A. I want to find the height of a node A. So, how to find the total number of edges from the leaf node to a particular node in its longest path. So, the leaf node is I and J. So, I am going to find the path to the root node in its longest path. We have to consider the longest path. So, this is the longest path. So, what is the height? 1, 2, 3. So, the height of node A is 3. So, if you want to consider from this, it is a right subtree. So, if you consider this path, because this is the longest path to reach root node. So, this is the shortest path. We cannot consider this path. We have to consider only the longest path. So, the height of the root node A is 3 itself. If you want to find the height of node B, node B is 1, 2. You have to traverse like this to reach node B. Height of B is 2. What about height of C? Height of C is also 2. Height of node C is 2. So, height of node E is 1. Height of node E is 1. And height of node D. So, D node does not have any child node. So, this is the leaf node. D and F are the leaf nodes. Hence, the height of this node is 0. Height of this node is 0. D is 0. F is also 0. I, J, K as well as node H is 0. Because these nodes don't have any child nodes. Hence, the height of these nodes are 0. So, next is depth of the node. So, what is the meaning of depth of the node? Length of the path to its root node is called as depth of the tree. Depth of the tree, length of the node to its root node. So, if I want to find the depth of A, so this root node A does not have any predecessor, means it does not have any parent, right? This root node does not have any parent, hence the depth of this node is 0. Depth of this node is 0. When it comes to node B, the depth of this node B is 1 because the parent of this node is A. Hence, the depth of this node is 1. What about node C? The depth of this node C is also 1 because B and C are the child nodes of root A. Hence, the depth is 1. What about root D? The depth of the root D is 2 because the root node of D is B. For the B node, the root node is A. For D, for the node D, the parent node is B. For the B node, the parent node is A. Hence, the depth of D is 2. For E also, it is same. The depth is 2. For F also, depth is 2. For G, the depth is 2. It has 2 nodes. Depth is 2. For H also it is same. When it comes to I, J and K, so the depth of I node is, I am going to represent it in yellow color. The parent node of I is E. For the E node, the parent node is B. For B, the parent node is A. Hence, the depth of this node I is 3. It is also same for J node. So, for K node, for this node, the parent node is G. For this node, the parent node is C. For this node, the parent node is A. Hence, the depth of this node is 3. This is how you have to find the depth of a node. Path. So, what is path of a tree? The sequence of nodes and edges from one node to another node is called as path between two nodes. So, consider in this example, so what is the path from A to J? I want to find the path between A to J. So, path from A to J is A to B, B to E and then E to J. So, the path between A to J is A to B, B to E and E to J. So, this is the path between A and J. So, if I want to find the path between A to K is, I want to traverse from A to C, C to G, then G to K. A to C, C to G and G to K. So, this is the path between two nodes. It is nothing but the nodes and edges between the two nodes is called as path between two nodes. Next is subtree. What is a subtree? So, every child node forms a subtree on its parent node. See in this example, A is a root node for B and C. So, B has 3 child, that is D, E and F. And C has C has 2 children G and H. So, G has K as its child node and E as child as its I and J. So, in this example, B and C are the child nodes. So, this is the left subtree and this is the right subtree. So, this is left subtree and this is the right subtree. So, each child node forms a subtree. So, each child node forms a subtree on its parent node is called as subtree. So, these are the terminologies of tree. Now, let's see what is a binary tree. So, next is binary tree. What is a binary tree? In a normal tree, a parent node can have any number of children. But in a binary tree, it is a special type of data structure where parent node have a maximum of 2 nodes. Maximum of 2 nodes. So, consider this tree. So, this tree has a root node called A. So, this is the root node. So it has two child node. So this child node B has two sub-child nodes, that is D and E, and this node has two child nodes, that is G and H. So in a binary subtree, each node must have maximum of only two nodes. So in the binary tree, it consists of a node. It consists of a node, left subtree as well as right subtrees. It has a node, that is a root node. This is the left subtree and this is right subtree. So a binary tree is a special type of data structure where each node should have maximum of two child nodes. It consists of a node, left subtree and right subtrees. So what is a node? A node is where it is going to store the information or the condition. Next is complete tree. What is the meaning of complete tree? Tree in which each leaf node should be in the same distance from its root node. See in this example, D, E, G and H are all the leaf nodes. The node which does not have any child is called as leaf node. So these are all the leaf nodes. So all the nodes are at the same distance from its root node. Check the length of the leaf nodes from its root node. All are at the same distance. So this type of tree is called as complete tree. So this is about tree data structure. Next type of data structure is graphs. A graph is a set of vertices and edges to connect between them. A graph is a collection of vertices and edges to connect between them. To connect between them. So what is a vertices? The collection of nodes is called as vertices. A, node A, D, C, B and E are the vertices. These are all the vertices of the graph. So what is the meaning of edges? The connection between the two nodes is called as an edge. So the connection between A and B, this link is called as an edge. Next, in graph there are of two types, that is directed graph and undirected graph. So a graph with directed edges is called as directed graph. So in this example, there is no direction, right? There is no direction between A and D. So if I provide a direction like this, then this type of graph is called as directed graph. A graph with directed edges. If an edge contains the direction, then this type of graph is called as directed graph. So what is undirected graph? If a graph does not contain any edges, any directions, so such type of graphs is called as undirected graphs. What is neighbors and adjacency? Neighbors and adjacency. A vertex, that is the end point of the edge, is called as neighbor of a vertex. That is the starting point. So what is adjacency? So in this, the first node is adjacent to the second node. The first node is adjacent to the second node. So what is neighbors? A vertex which is end point of an edge is called as neighbor of a vertex. So this is about nonlinear data structures. So in a nonlinear data structure, the elements are not stored in a linear manner, which is nothing but which is not stored in a continuous memory locations. So in nonlinear data structures, there are of two types, trees and graphs. We have studied about trees and what all the terminologies comes under trees and about graphs. So this completes this chapter. So in this chapter, you have to mainly concentrate on the algorithms as well as the definitions. Thank you.